Hello everyone, I am Linyu Li. Today, I am privileged to present our work, LiSum, Open Source Software Lessons Summarization with Multitask Learning. Open source software facilitates software development. Despite the benefits, users of open source software are expected to conform to the conditions stated by open source software licenses. These licenses regulate the conditions under which open source software can be legally reused, distributed, and modified. Generally, an open source software license plays the role as a contract signed between the software owner and the user who reuses the software. Once a user does not conform to the conditions stated by licenses, license violation occurs, and legal risks are induced, such as copyright infringement. However, these licenses are always long and complicated, so it's often hard for people to understand these licenses. Moreover, there might also exist multiple licenses in one project, which further complicate matters. In recent years, custom licenses with flexible expressions are becoming increasingly common. Manually extracting the detailed information from these lengthy and complicated licenses is both time-consuming and labor-intensive. The aforementioned reasons indicate an indeed need to help open source software developers and users understand licenses, as it ensures compliance with legal obligations and avoids potential legal issues. To study the necessity of license understanding, we conducted an online user study in both English and Chinese. The contents of two questionnaires are consistent across languages. Specifically, we recruited 661 participants via two online research platforms and utilized systematic approaches to filter out low-quality responses. The demographics of the participants can be seen in Table 2 on the left. We collected the perspectives and practices of the participants towards open source software licenses. Figure 4 on the right displays the attitudes of the participants towards open source software licenses. It can be seen that the participants in Prolific and those in Wenjuanxing have similar feelings of open source software licenses. In summary, a tool to help users understand open source software licenses is necessary. There has been a lot of research work done on text summarization with promising results. But there are three new challenges when it comes to license summarization. Firstly, the available dataset of licensed text was small-sized and low quality, which restricts the performance of language models. Secondly, licensed text is usually complicated and written in a formal language, which is different from natural language text. Furthermore, as you can see from the figure on the left, there are high correlation between license term classification and license summarization. However, general summarization tasks will simply treat license text as plain text. Given that the current public datasets suffer from the issues of being low quality, we construct a high-quality dataset of license summarization. Specifically, we first selected 210 licenses, covering all 23 mostly used license terms, as you can see from Table 1. Then, 4 authors independently produced summaries and then voted for best one. To evaluate the quality of our dataset, we included relevant questions in our user study. We firstly took 3 popular licenses as the examples and asked the participants whether the summaries in our dataset contribute to a quick understanding of the regulations stated by these licenses. You can see the according result from Figure 5. Besides, we also compared the labeled license summaries with those provided by the public datasets. To conduct a fair comparison, each participant was assigned 5 pairs of license summaries randomly selected from the 210 pairs of license summaries. 76% of the feedbacks reflected the preference of the summaries we labeled compared with those in public datasets. Due to these challenges, it is necessary to propose a novel approach for license text summarization. Specifically, we propose a multitask learning algorithm which leverages the correlation between the license text summarization and license term classification to incorporate more information and make the model focus on the rights and obligations indicated by the licenses. The figure depicts the overall architecture of LiSum. Specifically, LiSum consists of a license summarization module and an attitude classification module. In this architecture, the bidirectional encoder processes the input license text and generates contextualized representations at each token position. The autoregressive decoder is responsible for the text summarization task. Moreover, we introduce a novel term attention module designed specifically for attitude inference. This module enhances the model to focus on specific license terms during the classification process. Consequently, our model can effectively extract relevant information for each term, even from lengthy and complex licenses. While keeping the number of additional parameters to a minimum, the license representations from the encoder and decoder are fed into the term attention module to acquire term-specific representations, which are then concatenated to create a fused representation. This fusion aims to capture complementary information, effectively enriching the understanding of license terms. The design of our license term classification module stems from two primary considerations, both of which are deeply rooted in the essence of license understanding. First, valuable feedback from our user study suggested that presenting structural information with highlighted attitudes could significantly improve license understanding. In response to these concerns, we developed the license term classification module to automatically infer attitudes toward key license terms, thereby highlighting crucial aspects of the licenses and facilitating users' comprehension. Second, from a technical standpoint, the classification module plays a pivotal role in our multitask learning approach. As mentioned earlier, license term classification and license text summarization share inherent correlations. By simultaneously learning both tasks, our model leverages their interplay to enhance the overall license understanding process and generate more informative and concise license summaries. For each license term, the input is an original license text, and the output label is one of the four possible attitudes: can, cannot, must, or not mentioned. Therefore, the attitude inference problem is formulated as a multi-class classification task. We first extract license representations from the transformer backbone. Specifically, we obtain license representations from the encoder and that of the decoder. Then, we design a term attention module that learns to attend different hidden states according to different license terms. For the ith license term, we can obtain the attention weights using the first and the second equation, respectively, where alpha I and beta I are attention weights on HE and HD, respectively. UE and UD are learnable context vectors corresponding to the ith license term. Then we can obtain a term-specific license representation by the weighted average of the hidden vectors. We concatenate the two term-specific representations to achieve the final term-specific representation and develop a multi-layer perception as the classifier. Finally, we conducted comprehensive experiments to evaluate the performance of LiSum. First, the evaluation on license summarization showed that LiSum base and LiSum large outperformed all baselines with gains of roughly 5 points on all F1 scores. Then, the evaluation on license term classification showed that LiSum can effectively identify the attitudes of license terms included in the license text, outperforming all state-of-the-art baselines by large margins. In summary, we released the first high-quality dataset for license summarization, and we propose LiSum, a multitask learning method to help developers understand the open-source software licenses. We made all the datasets and the replication package publicly available to facilitate follow-up research. That's all my talk. Thank you for listening.